a cylinder?
And prisms.
If
And prisms. This is the surface area of cylinders and prisms.
where?
I don't know.
If you look at a cylinder there, children, and we do the net of a cylinder, what is the net of a cylinder? What would you, if I asked you to draw the net, which means if it was a cereal box, actually it would be one of those oatmeal boxes. What shapes would you have to make an oatmeal box? Well, you've got the top and the bottom circles. Now that looks like a prism right there. But to that attached, you'd have the rectangle that would make the label of the thing, you know what I'm saying there? This is the tube. If I had a tube, does anybody have a tube? I did have a tube. Somebody know what the tube was? Either way, if a can is made up of two circles on top and the label around the side, which ends up, if you unfold it, a rectangle.
I think I can see.
All right, Jack, we're moving on here. And in order to do that then, if you're looking for the surface area of this, what do you have? You have two circles, and that's where this formula comes from. Surface area equals 2 pi r squared. It's 2 times pi times radius, because that gives me the two circles. Okay, that's my top and my bottom circle. And to that, I have to add whatever the area of this rectangle would be. And the area of the rectangle is the height of the can, which is this, plus, what is this right here, do you know? That's what gets wrapped around the circle. What do we call the wrapping around the circle? It's the circumference. So, and circumference is pi times diameter, and then I have to multiply that by the height, like I just said. So this is your formula for surface area of a cylinder. 2 times pi times radius, you do that, and to that you add pi times diameter times height. So let me give you the, for example here, let's say you've got this kind of long, skinny sort of looking tennis ball can, and its diameter is 8 inches, and its height is 14 inches. You just need to simply plug this into your formula. It's just going to look like this. Surface area is going to equal 2. I'm going to leave it in terms of pi so we don't have to mess around with pi for right now because I don't want to take that much time. What is my radius? 4, because my diameter was 8. That's the first part. 2 times pi times 4 times 4, which actually gives me what? 4 times 4 is 16 times 2 is. I get 32 pi's. Plus pi times, what's my diameter? 8 times what's my height? 14, I believe. So 8 times 14 is, right? Yeah, 8 times 14 is, come on, people, somebody can do that in your head. 112, thank you very much. Did you do that in your head, Jackson? Okay. And then notice the nice thing with surface area is here, these both end with pi's, so if I have 32 pi's, and I add another 112 pi's to them, I can actually put those together. I get 144 pi. And it is in area, so it's inches squared. Now if they ask you to, if they tell you what pi, did I do something wrong? If they tell you what pi is and they want you to do it, you'd have to multiply all that by 3.14, which is, gets a little ugly, but I don't want to take the time, and I know most of you can multiply. John?
Can we cross influence since it's part of the responsibility cross off and labels pi?
No, because both of these, when you do this, are on top. If you make them fractions, are on top. And you are adding, by the way, not multiplying. If it was multiplying, then it'd be pi squared, but it's not. No cross canceling here yet. Anyway. Got that? It's really not a complicated thing if you have the formula. But again, if it comes up on an assignment, you certainly just need to write the formula down and fill in all the blanks and do that there. Now, the other surface area one we have to talk about is surface area of a prism. I don't even want to go there, but I'm gonna guess, oh gosh, see this just gets nuts. I don't know if I have enough time in this week to describe this. The surface area of a prism is really this. This is what it boils down to, and you may or may not understand it, and I guess that's just the way it works here. Surface area of a prism equals the lateral surface area plus 2 times the area of the base. You may have to put your thinking caps on for this. I'm going to let that sink in for just a minute. Yeah, this is incredibly difficult. Let me draw a shape for you here. Let me put some measurements on that shape. Let's try to make it easy. Let's make this 10. I wish I wasn't drawing so big. Let's make this 10, 20, and the height, let's make 8. And let's make these sides all 10. Can I do that? Okay, in order to understand the formula, let's start with the base. We've talked about base before of prisms, right? What was my little theory on the base? Nick?
Slice of bread.
So the slice of bread thing. When you're thinking about the base, it has to be like if it's a loaf of bread, you keep getting the same shape. Okay, so that's the base. Base is the loaf of bread. Now, and the reason why there's 2 of those, I'm looking for the surface area of this. By the way, the ancient, archaic way of doing surface area was just to label all the sides and say, okay, the surface area of the front, surface area of the back, surface area of the right side, surface area of the left side, surface area of the bottom. That still works. We kind of go a little, you guys are getting a little deeper into math, so they kind of make it a little bit easier here. Okay? But the base, why is it 2 times the area of the base? Because there are always 2 shapes that are identical, and those are always going to be your bases. They're both triangles. Okay? So I have 2 times whatever the area of the triangles are. What is the area of the triangle? Well, we know triangle is 1/2 base times height. The base of the triangle was 10 and the height was 8. So 2 times 1/2 of 8 times 10, which is, what, 40? Did we get that? Is that right?
Yeah.
And then 2 of those, right? Did I get 2 of those? Yeah, so this ends up being 80 for this part right here. Now that leads us to what in the wide world is the lateral surface area? The lateral surface area is this. In reality, it is the area of all the sides. And that means not the bases, which just kind of makes sense probably to you. So on this, when you're talking about the sides, you're talking about if it's set on its base, it's going to be the area of all the sides. And this thing has this side, it has its bottom side, and it has this left side here. Those are all the sides that surround the bases. Okay, those are the sides we're talking about. And the lateral surface area itself has its own formula. Lateral surface area equals the perimeter of the base times the height. How much time do we have? Not much. That means this. To find the lateral surface area, you find the perimeter of the base. What would be the perimeter of my base? It's 10 plus 10 plus 10. That's this shape. Okay, that's 30. And then the height is, if it's sitting on its base, how tall is it? 20. So 30 times 20 is 600. Now let me tell you what that is, ladies and gentlemen. What that is if you would have found each one of these sides by itself, this side would have been 10 times 20, which is 200. The backside here that you can't see would have been 10 times 20, which is 200. And the bottom that you really can't see is also 10 by 20, which is 200. When you add all those together, you would still get your 600. Lateral surface area is a much quicker, easier way to do that. Now my total surface area is that lateral surface area plus what I said, the 2 times the area of the base is. So my total surface area, maybe I should put that down here, is 680, whatever it was, inches squared. Wasn't that like just astounding? And I know nobody got that. I understand. I've lived in the world before. Let me look over here. What are the odds I actually have enough of this? Yes, I do. Back in the day, children, I spent a good amount of time writing this little total surface area chart here. And you look at the little subheading says what? You're a handy-dandy guide to find the surface area of anything. It's really much more complicated than it needs to be. And I can't change that. I can only help you try to change that. I'm hoping that just maybe, before you get out of this crazed asylum, you will be able to do total surface area. Now what I should do, and what I will do, let's pick a problem. Somebody look at a problem. And I'm going to fire up a sheet. Where do you think I would find this? Under math stuff? Let's go under surface area. What? Is there no surface area? Systems of equations. Maybe it's under area? Why can I not have any surface area? No, I don't delete. I don't delete. Maybe it's under area. It probably happened so long ago I probably didn't put it in a category. Let's look under here for surface area. Ha ha ha! Surface area. Take a look, see here. Does that look familiar?
No.
Sorry. Here you are. I'm going to walk you through this in baby steps. Just so you know exactly, when you run across one of these problems, the kind of issue. Which one did we come up with? I want something tough, difficult. No, A is a cylinder. You don't have to do this for A. B is one like we just did. I really don't want to do B.
C. D, E, F, G,
E. No.
Example 3.
Example 3. Well, they ask you to find the lateral surface area. That's not what I'm going for either. Maybe I'll wait on this. Hold on. Problem number 10?
Let's just have a dance party.
No, I can't use surface area of cylinder.
Mr. Harper's dance party.
Inside this box. Look for something that comes from set number 85. Hold on a second. I'm going to go to another set. Set 85.
Set. 80. Number 5. Number 4. Number 4 on set 80.
No, number 4 is a pyramid.
No, 87.
Oh wait, 87 I hear one here.
I don't know, it looks weird though.
No, that's not it. Maybe there isn't one. Maybe I'm just going to give you something and we'll come back to this.
Number 6.
On today's?
No, on set 88.
88?
Yeah.
Alright, let me look. 6 on 88. Okay, well, I can tell you number 6. Let's do number 6, but it doesn't ask you for total surface area. That just asks you for lateral surface area. So let's just say we are working with this thing here. Let's just say we got this. So the first thing you do is you sketch. You go ahead and sketch this as best you can from your page there. It is a triangular prism whose dimensions were 1.5 by 10 inches. And what one must kind of comprehend here is it gives you some instructions in there that you also need to read, where it said the lateral surface of this triangular prism with an equilateral base, which means what? Because that's important. Equilateral means all sides are equal with the triangle. So all of these are 1.5 inches. Okay. Now they're just asking us for the lateral surface area, so we only need to find this part right here. Well, we need to do 1 and 2. That's 1 and 2 is the part we're going to do. So the first box over here says draw the shape of the base. What is the base? It is a triangle. So you draw your triangle and go ahead and put the dimensions on there. What is your triangle? It is 1.5 all the way around. Correct? And then it asks for what is the height that is perpendicular to the base. So if the base is this triangle, what number is perpendicular to this triangle? If it's setting on its triangle, it is 10 inches high. So this is 10. And then it says to find the lateral surface area, you find the perimeter of the base. What is the distance around this base? 1.5 plus 1.5 plus 1.5 is 4.5. What is the height? 10. So the lateral surface area is what you get when you multiply the perimeter of the base times the height, so your lateral surface area is 45. Now, if you were finding, you can't. Why can't we find the total surface area? Jeremy S. Wars? Yeah. On this base here, we're not given the height of the triangle that you would need to find the area.
We could make up.
We could. Let's make it 2. Because that'll make life so much better. So I draw the base again. I know it's 1.5 by 2 high. What is the area of that? Triangle is 1/2 base times height, or 1/2. What's half of 3? Huh? Oh, look at that, 1.5. Times 2, because there's 2 bases. Again, the reason why we multiply by 2 is there's 1 base there, same identical base back there. So you get 3 for the area of both bases. And then over here, you finally add all that together. 45 plus 3 is 48. And that would be, if you like that sheet, there's more of them back there. But you don't have to do that with cylinders, people. Cylinders, you just have to plug in the formula. This one here, there's no formula. All right, with that being said, and you having 7 minutes left, I will give you something to do, but I just don't know what.
Quiz. Dance party.
No, you don't have enough time for a quiz.
Dance party.
Ron, well, I heard the first 15 dance parties, and it's kind of old. I don't need any more. Perfect. We're on 85. Let's do.
Let's do very hard stuff.
No, let's do 13 through. Just 13 through 17. 85, 13 through 17.
Yeah, no.
Which chapter to talk about? Because you'll probably give you a chart for that. Then look and see on that.
Who's up today?
So what are we on?
I think it's the first.
Brandon.
Oh,
Yeah.
let's say a prayer. You guys have a good day, and I pray that you have a good lunch and a good rest of the day. Sure. I completely did the first one.
You have a good nice little drawing? Sure detention to you, is it? Is that what it says? Just today. Yes, it is. I don't do anything today.
Yeah.
Yes.
Is Mr. Hahn in here? No. Okay.
Bryce, what do you got?
10 minutes.
For what?
We're talking in the pickup room.
Going?
Then,
What's up? That?
Study hall.
No.
Why are you here?
Brandon. What's that? Time to people go.
If you're gonna come in here and work. Everybody else.
You should see the picture.
My brother. I'm too cute every day. Yeah. Bash. Oh my gosh. Archie's gonna kick your ass.
You.
Lollipop. Yeah. Lucy. Holy crap. Dude, his tongue like Russian blood. It's not there anymore. It's not there. I swear it disappeared. Take them. You want to really Everyone's like, congratulations on getting his bus license. Congratulations on bus license. Did you get it? Did you get it? What?
Here we go.
number, what are we at, 1, 2, 8, that's a lot better. 91.
Oh, we're gonna do this, so.
Geometric formulator. Number 1 was 1/2, I believe. Prime to composite. Number 2, 11 hours, 30 minutes. 11 hours, 30 minutes. Number 3, 8. Number 4, 1 more greater. Number 5, area equals base times height. You get 60 centimeters squared. 60 centimeters squared. 6, 270 degrees. 270 degrees. 7A is 4 faces. B is 6 edges. C is 4 vertices. Number 8, A is 44 inches. B is 108 inches squared. Number 9, A is 0.35. B is 35%. 10 is 240 feet. 11 is 8 5/12. 12 is 3 3/5. 13 is 5/8. 14 is 6. 15 is 1/15. 16 is 2/3. 17 is less than. 18 is 25%. A is 1/4, sorry. B is 25%. Number 19 is 50 seeds. 20 is 1 2/3. 21 is 16. 22 is 12 feet squared. Anybody have 24? Perfect. You're wrong. 23 is 1,728 inches cubed. 24 is 3 squared times 5 squared. 25 is 30 millimeters. 26 is 7 8. 27 is 15. 28, you should have some sort of a diamond-shaped thing sketched out. Let's take a look at that one. And again, I've been encouraging you to use the lines that are already given you on the thing, not to draw some willy-nilly things in the middle of nowhere. And it looks like we may be making some progress. In all honesty, ladies and gentlemen, you don't need, if you just draw the two axes, the x and y axis, you really don't need to draw all these little lines because they're already on your paper. If you know what I'm saying. Some of you do and some of you don't. Alright, number 29A, 4 whole squares. B is 8 half squares. And C, the area of the entire square would be 8 square units. So if you have 8 halves, that's the same as another 4. And number 30 is 1/8, which is 0.125. Yes, Gary.
What was number 16?
Number 16 is $1.15. I will put a check out.
What was number 23?
23, 24 centimeters squared, sorry, wrong one. Wait, no, that's right. No, 23 is 1,728 inches cubed. Right?
What was number 10?
10, 240 feet. Kendall?
What was number 3?
8. Charlie? 5 was 60 centimeters squared. Okay.
What was 11?
11 was 8 and 5/12. Sam?
Maybe 6 and 4.
Probably. Questions or answers first? Yeah, Dave?
It was 21.
21 was 16. Alan?
30.
30 was 1/8, which is 0.125 as a decimal. Problem number 6 is how many degrees does the minute hand of a clock turn in 45 minutes? So the question is, you've got a clock. Okay. Let's say it starts there, correct? The minute hand. In 45 minutes, it's going to go and end up right here. So they want how many degrees this turned here. And this is 90 degrees. Turning straight down would be another 90 degrees, and then turning one more time is 390 degrees. It's 270 degrees.
That was hours. 45 hours.
45 hours, that would be interesting. That would be what, almost 4 whole turns. I hope you got somewhere in the thousands.
Yeah, I did. I got 16,002.
No, that would be 16,000 would be way too big. 45 hours? Oh,
45 hours.
40 times 30. Fine.
Yeah.
Hours.
Oh, can you do number 30 on the board?
John will toss a coin 3 times, so the probability the coin will land heads up all 3 times. And again, for that one, I would suppose one would draw 3 coins. The probability of getting heads all 3 times. We write that out mathematically like this. Probability of a head, head, head. And the way you figure that out is, it's the probability of each event happening times itself. So what is probability of flipping a head here? 1/2. Probability of the head here, another half. Probability of another head there, half. Probability of all 3 of them happening is 1/8. Multiply them together. Okay?
For 20 would be good if I put 1.6 would be good.
Sure. Again, I don't know why you want to do it that way, but it went. Holly?
Can we do number 26?
On a number line, the square root of 60 is between what 2 consecutive integers? Well, where is the square root of 60, Holly? Square root of 60. Think about, what does that mean? What same number times itself gives you 60? So this is trial and error. Pick a number. Any number. Huh? 2. So you multiply 2 times 2, you get 4. Time low for 60. Square root of 4 is 2. So let's try something higher. What about 4? Well, 4 times 4 is 16. So the square root of 16 is 4. Still too low. You want to get up to 60. So 5 times 5, well, that's 25. Still too low. 7 times 7 is 49. We're getting closer. 8 times 8 is 56. That's awful close. Still too low. 9 times 9 is 81. So you know this square root of 60 has to be between 8 because, I'm sorry, 8 times 8 should have been 64. You know it has to be between 7, which is 49, and 8, which is 64. That's all they're asking. Between what 2 integers does that have to be? Doesn't matter. Again, remember it's not 60 divided by 2. People are getting that confused all the time. It's not half of 60, it's what number times itself gives you 60. Kendall.
You do 27 more.
Again, I can't, there's no magic formula for this. Kendall, well, what times what gives you 225? I can't, I mean, there's no way to set it up other than you just gotta keep trying different numbers. You know, I would start with 10, I suppose. What's 10 times 10? 100, that's way too low. Go with 20. What's 20 times 20? That's 400, well, that's too high. So you know it's gotta be between 10 and 20. I'll try
I
one
said the
here.
wrong one.
Huh?
I'm sorry, I said the wrong one.
Alright, which one do we have?
21.
21. W over 20 equals 12 over 15. So tell me how you go about doing this, Kendall.
I multiplied 20 times 12
You got?
240
And then did what?
and then divided it by 20.
Why would you divide it by 20? If you multiply it by 20, why would you divide by 20? You're gonna end up with 12, the same thing you started with. What are you supposed to divide it by? Well, it's this times this equals 15 times W. You should divide by 15. And that's what's gonna give you the answer. Yep. And by the way, you can't cross cancel here. Some of you are thinking that's not multiplication, those are two equal fractions. Alex?
Did you get your bus driver's
I did. Alex?
19.
Number 19. What's the word of mean?
Multiply.
Okay. And what are you trying to find? It says 5/8 of the 300 seeds. Well, you can just draw this. This stands for 300 seeds, right? It said 5/8 sprouted. Cut this into 8 equal pieces. Okay. But the issue they asked was how many did not sprout. I don't know if you found 5/8 of that thing. If you divide 300 by 8, what do you get?
300 by 8.
Is that the right formula?
No.
What was it supposed to be? 600 divided by 8?
No.
300 is supposed to be
300.
Oh, it's 5/6?
Yeah.
Oh, I'm sorry. That makes sense. So each one of these is 50. So they wanted 3/8 because 5/8 did, 3/8 didn't. So 3 times 50 is 150 would have been. Did not sprout. Wait, no, 1/6. They wanted 1/6?
Yeah.
1/6 would be just 50 then. If that sprout. Is that the issue there?
Yes.
Last one, Sam.
Did you do 23 on the board?
Did you draw the picture?
Yes.
And you drew the cube, what's the volume in cubic inches?
I got 21 there.
Well, first of all, it asked it in cubic inches, so I'm not sure how you got feet as an answer.
Oh.
It's 12 inches by 12 inches by 12 inches. Volume equals length times width times height. 12 times 12 times 12. I'm not gonna do all that multiplication because I'm really lazy right now. We need to forge ahead here. If you have other questions, come talk to me over there when we're done here. We'll get those answered. We gotta forge ahead here. Take out your notes under expanded notation. Seems to me we did this, but yeah, but have we done it with exponents?